capacity said, look, this isn't going to make a difference. I know it would make a difference. The more you don't want to do it, the better it is. Now, we'll go through and we'll work for something that says, stop. I mean, 20 minutes.
That's
This
fine.
isn't bargaining, I'm sorry. 20 minutes. Either we stop or we can go to full time. You're not going to school full time. See?
No.
Varsity. Mod B, maybe cut. Now, take a look. Go through right now, please, and I want you to answer out the first question. Read what's there. Calculator's active. I don't think you need it for this question. Well, maybe you do. We'll see. If you need it, it's available to you. So to read what's there, understand that on the AP you have 2-ish minutes, 2.5 to answer this. Now, as we look at this, the first thing you're going to look to do is identify all of the given information. So, based off of what's there, what is, Leah, what's one thing that's given?
The change in the constant rate of the radius is supposed to decrease with like 1.
So the change in radius with respect to time would be what? Negative 0.1, and let's make sure we've got the unit, so it will be centimeters per second on it. We need to go through knowing that, and in terms of the circumference C, what is the rate of change of the area of the circle? So what base formula am I going to be working with in order to solve out this question? Which one of our regular old geometry formulas would we be using for a question like this? Abby, what do you think? Close. We do know that circumference is equal to 2 pi r. What's this asking us to solve for? The rate of change of what? Area. So in order to find the rate of change of area, first thing you need to know is your area formula, which is? So I need to take the derivative of that and all of its variables with respect to time. So, Megan, what would you have on the left-hand side if you took the derivative of the area with respect to time? What would that leave you with? Now on the other side, what would I now be left with on the right-hand side? Jack?
2 pi r dr over dt.
2 pi r times dr over dt. Now our goal is to solve for, in terms of the circumference, what is the rate of change of the area. So I need to figure out what the change in area is going to end up being. Except one of these things is kind of interesting. And when I did this out, you might have seen, when I was doing this, I erased this because I remember from last year to this year, there's actually an efficient way to do this if you know your stuff. Something's up there right now that ties into the question. Mike?
2 pi r is c.
So I'd say the change in area with respect to time is equal to 2 pi r is the circumference. So c times the change in radius with respect to time. What would we do from here, Sierra?
It was plus and negative 0.17.
Is that a choice? What did you get? Let's hear it for us. Right?
I got B.
Oh, B, sorry. B. Correct. That's what we get. Questions on that? Take a look at the next one. When we go through and do this, read and sketch this out. You tell me, get going on this, because there's a lot there you should be able to unpack. Again, understand that on a question like this on the exam, you would have, actually, I'm sorry, do this right now in your calc. You take 55 divided by 17. Give me what that is as a decimal. 55 over 17. I know it's 2 and some change. How much is it? Oh, what is it? So 3.2 minutes per question on a calculator active one. And this was Calc active. So go through right now, sketch out what you need to do for 90. Is that what it was? Yeah. Identify all the criticals that you need to. Calculator is active if for some reason you need it. I did not need it when I was doing this one out. And you'll realize that on the calculator active. Even with the calculator, you don't need all of it. Mike, what would you go through and draw to start this off? What shape are you going to draw? Good. More specific, what kind of triangle? Everybody know what kind of triangle I stick here? I wouldn't change it as equilateral. I'd make it a right triangle. Because it talks about base and height in here, doesn't it? Yeah. So, now I also need to identify what are my knowns. So I know this. What other information at this point do I know? What can I unpack from this question? We got one person. Get real. Steve? Is going to be what? So the change in the base with respect to time is positive 3 inches per minute. Now let's put the units on it because you're taking the derivative of everything with respect to time. And then, Josh, what else do we know?
Height is decreasing at 3 minutes or 3 inches per minute.
So what would you write out?
D H over dt equals 3 inches per minute. What?
Good Larry over here. What, Leah?
Negative 3 inches per minute.
Did you say it was decreasing? You're better than that.
Thought you knew that. I don't like to imply.
Yeah, don't imply, especially at your level. Now, when we do this question out, you're figuring out which of the following must be true about the area. So we need to figure out, with these changes going on, is the area always increasing, always decreasing? Is it increasing under conditions, or will it remain a constant? That means right away I'm going to have to go back to, I'm looking to find out what's happening to the area, so what base formula will I need to be working off of for this question? Look out, MIT, we got a whole 2 of you? Outstanding. 3 of you. Look out. Woo! I think the Ivy League recruiters will show up directly here. I mean, one deep talent for Good start, you're right. What was the question? Thank you. Now, by the way, when we're doing, I treat it as 1/2 base. Same thing. Now, to go forward from here, because the half needs to go somewhere. Looking at that, I need to find what the rate of change is. So, Noah, what needs to happen in order to go through and proceed forward? What would our next step be? We identified the formula. Draw everything out, labeled what we, all of our notes. Okay, so what's the derivative of this going to be on the left?
dA over dt equals would just be 1/2 and then dV over dt dH over dt.
No. What did you say it was? 1/2 what? No. What do we need to do in order to take out this derivative? Have it? Product rule. So, what did you say? Little bit, just a little bit. So now, what are you going to go through and write out?
1/2 B, 1/2 B dH dt.
So, yeah, or h times 1/2 of this, which would be 1/2 what? Now, when we do this out, we're to here. We can actually fill a whole bunch of values in at this point. What can we plug in at this point, Steve? Is? And then what about the change in the base with respect to time? What would you think about someone who had left off the negative that's on the change in height? Would you talk to that person? What? They don't get to sit at the lunch table? That's a fair assessment. What's that?
I thought you were going to go through with that one.
You've already been nice to them.
Now,
See, it's different. You're right. It's
they walk
different.
away.
If there's a calculus error, that's more important than anything. And calculus is way more important than being nice. But in other classes, the errors don't matter, except science, maybe. There you go. Now, let's condense this down, and I'm sure that it'll be a lot for you. What do we get if we condense this down here and this down here? Take a minute, let that marinate for just a second. Thomas, what are you going to simplify that down to? The derivative of the area, or the change in the area with respect to time, going to equal. No. Well, yeah, we're going to evaluate. What does this become? You were going to say -1.5. We would never say that. What would we say instead of -1.5? Times? Okay. Plus, what goes over here? So now, this expression right here represents what the change in the area is at any given time. Which answer would we go through and give? Two people. The change in the area is equal to that. That's what you got, it's equal. Two people. Three. Abby? That's scary. Good. Did you get? Is A always increasing? Is the area always increasing? Is the area always increasing? No. Is it always decreasing? No. So we've got this. Is it constant? No. All right. So it's decreasing when B is less than H, or it's decreasing when B is greater than H. Which one of those is true? What? When the B is greater, that causes a negative area rate of change. So that's what we would go through and get. Questions on that? What?
Sure you like your talk like that?
Yes.
Just scary.
Yes. So
What does
start.
it do? Like, when you scream
he has these allergies, and we have to take him sometimes to a hospital to go to Cornell Animal Hospital to go an hour and 40-minute drive each way. So they have this experimental drug that he's on now to stop for when he itches. So he gets this injection. For when he itches, he'll yell. He'll be like sitting there and he'll start scratching his head. No! They're going to tennis all the time. I didn't know. Have any of you seen him before? You did? Yeah. Is he vicious?
When's the new dog that worked there?
I don't know.
And
There was
get matching crystals while they're
no. There would be sort of one day. Maybe we can sit him in the desk or something. What your task is going to be over the break is going to be to go through and finish these 3 questions. I'll say this: we can actually do one kind of quick. Take a look at the 2002 AP Calculus Form B1, the last one on the page. You may have enough space to go through and get that one done. I'm not 100% sure. Looking at what we have for this question here, though, read what's there, I guess. Label as much as you need to on that picture. Yeah, look at your picture. Label as much as you need to. We'll give you a little while to get a head start on it, which means we're not going to have as much patience if you're not bringing it. Josh, did they stitch it right into the sweater, the question? Is that why you're looking at it? I'm merciless.
No.
Seriously. So let's start unpacking this question, I guess, or at least figure out what we need to. It says, ship A is traveling towards the lighthouse at a speed of 15 kilometers per hour. Ship B is traveling north away from the lighthouse at that speed. Let X be the distance between A and the lighthouse at time T. And let Y be the distance between them as shown in the figure. Find the distance in kilometers between ship A and ship B when those constraints are met. Now, I actually am shocked that this is even a point. Who can tell me what's the difference between them at those particular distances? 5. Careful. If you gave me too much, you would actually lose the point. What should the answer be?
Oh, we did this, I thought.
Offensive.
No, you waited, and I didn't pull
You're
one.
right.
You waited.
No, if I wait long enough, you'll dig your own grave. So just keep throwing units on it and be like, kilometers per minute, squared, cubed, feet. Second thing, find the rate of change in the distance between them at that moment. Now, we need to also take into account all of the changes that are happening at this time. So, ship A is going towards the lighthouse, B is going away. So we've got rates of change to deal with. What formula am I going to be working with in order to work with this question? You tell me. How can I figure out what that distance is going to be between the two? Yeah. You could. Now, I'll say this. I actually did it a little bit different, so I'm not 100% if Pythagorean theorem would work. I think it might. We'll go through X. Fine. Since you said Pythagorean, we'll try it with Pythagorean I. So if I did that, I would say, what is this? The B part of the question? Let's try x squared plus y squared is equal to, was it s squared? The distance between them was s. Is that right? So let's go through now and take the derivative of this. So, Hannah, what would the derivative of this be? Now, there's a lot we need to clean up on here. Who can tell me, please? There's actually a bunch of changes that on here need to be made. Who can tell me what's one change I would need to make in here? No one sees any issues with this.
I'll subtract the 2y.
Nope.
So then you can factor out the.
Nope. What? Nope. There's things I want to change before this. This is not right, so stop going forward with this. Yeah. Yeah, we need, and more than that. Yes, over here, you're always taking the derivative with respect to time. So this would be 2x dx dt plus 2y dy dt and 2s ds dt. Now, based on what we're working with, maybe this can come out. So we're looking to find the rate of change between the shifts. So that means I'm looking to find the rate of change between the shifts. If we're using this formula, that means everything else is going to have to be solved for. So at this instant, what would my x be? What'd you say? 4. So, okay, 2 times 4 times, what's the dx dt? What's the is the x going up and down or side to side in this picture? Side to side, so what's the dx going to be? Negative 15 plus. Now what goes on the other side? We just got a hand out. Jake, what else would you fill in? Equals 2 times, what is the s value at this moment? So now this is going to be where it gets very difficult. So I'm going to ask you to do this. What's 4 times 15? Negative 60, and then multiply that times 2, and you get negative 120. Now 2 times 3, if you need to use a friend, you can. 2 times 3 is going to be how much? 6 times 10 is 60 is going to be equal to, over here, I have 10 ds dt. So let's do the drastic step of adding these together. That would leave me with negative 60 equals 10 ds dt. So what's ds dt going to equal? Now, what would the units on that be? And what is it? Kilometers an hour? Now, let's see if we did that right, because I did it a different way before. Yeah. So is that direct? Obviously.
But we just do it.
I went through and got s as a function, what that length was as a function, which is solving it for the square roots of 2 squares. Then this becomes this, which is a chain rule. Okay, so we took the derivative of that, and then we get this mess here. So I go through and say, well, all right, this would need to drop down to the denominator, and so on. And then this goes up to the numerator. So, yeah. Sorry. Listen, sometimes you all find a more efficient way than I. I am cursed. When I see things work, I only learn it one way. Now, we've got one last one to do, which is we need to go through theta be the angle shown in the picture. Find the rate of change of the angle in radians per hour when the x is 4 and the y is 3. Now, I'll say this. Some people actually did this a different way, because you could use any trig function I think you want to, because you're trying to find the rate of change of the angle shown in here, which would be this angle here. And you know the sides, right? Because this is, you're saying it's a 3, 4, 5 triangle. So this at that moment is 5. Did we say this was 4? This one's, the x is 4, this is 3. Sorry, thank you. So looking at that, now let's ask ourselves this. Which trig function are you most comfortable taking the derivative of? Hands up, please, when you can answer that. Because you all need to be, you're the ones who are doing it. You tell me. Which trig function are you most comfortable taking the derivative of? What? Okay, so sine in this case would be equal to opposite over hypotenuse. So in this case, I'll do this out. This would be for C. So it will be sine of theta is going to be equal to, now in this case, before I do my plug-ins, sine is opposite over hypotenuse, so y over s. Right? We define the hypotenuse as s. Times y. Now, I need to solve for what the y is, or sorry, what theta is going to be, but I need to find what the rate of change of the theta is first. So the first thing I'm going to do is, what is the derivative of sine going to be then? Okay? So this would be cosine of theta times the change in cosine of theta over the change in time is equal to, now why is this right-hand side going to get messy? What's that? Quotient rule. So it's low d high, so s times, what's this, dy dt? Low d high minus high d low, which would be what? Y times ds dt all over s squared. Now let's go through and solve this out and plug in what we can. What is our cosine ratio going to be? What's the cosine of theta equal to? 4 over 5 times d theta dt. What is the s equal to at this point? What is it? 5, right? What is the dy dt equal to? 10. And then minus, what is the y itself? 3 times, what's the ds going to be? Negative 6. You brought in what you did previously all over the s squared, which would be 25. So now let's simplify out our numerator. We've still got 4/5 times d theta dt is equal to, looking at this numerator going across, I've got 50 plus 18, which would be what? 68 over 25. Does anything go into both of those? Yes or no? No. So what do I do to solve for d theta dt? Multiply by the reciprocal, which would be 5/4. Now, I'm going to make this a heck of a lot easier for me to do, because watch what I can do from here. This becomes 1/5. And how many times does 4 go into 68? Who can tell me how many times 4 would go into 68? Yeah, because it's 4 goes into 40 10 times and then 28 more. So this would be 17. So is it 17 over 5? What, do we need to give units on it? There you go. Now, when I did it previously, I used tangent, which left us with secant squared for the derivative, which is made it a little bit awkward. So, those of you who are heavy hitters like Sam and can recognize things right away, you're at baller status, you would be able to identify that nicely. All right? Now, we finished with that. What? You're right, I'm sorry. Here I am thinking, right, I shouldn't collect a paycheck if I'm not going to sit here and instruct you for 55 minutes. Your parents should go to the school and say, no, no, no. The calculus teacher sat down and showed a movie for 20 minutes. I would like that fraction of my taxes back. And they'd be justified in it. Because what's my job to do? Show movies? Am I a projectionist over at Lowe's? Is that my job? And it's even a farce, because I'll tell you this. Guess what? Guess what I did today? This is part of a movie, right? You asked to see Home Alone 2. This is it.
I asked for one.
No. Oh, it's one? Wait a minute, because I did. Okay, sorry. Ready?
That's 2. That's from 2.
No, that's your stuff.
Not in New York City. What?
There. Oh, it's not moving. I found a nice one here.
Oh, the first, that's the pizza guy.
Yeah.
Oh, okay.
Yeah.
See, it only plays once. They got a little preaching. See? Maybe I just have a broken heart. Maybe that's why I'm not nice.
I told you, if you show
I already have high blood pressure. I told you my heart can't deal with that. Can you imagine if my heart grew 3 times and because of doing something nice for someone else, my blood pressure spiked and I keeled over and was no longer with you? How would that make you feel, knowing that my good act